Okay, in this section, determinants are actually, to me, easier than multiplying matrices. So I hope you like it as much as I do. So the first thing is it has to be a square matrix to do what we're doing with this determinant. So the determinant is, well, it has to be a 2 by 2 and a square, sorry. The determinant is basically, to me, it just looks like cross multiplication. Because if you look at this A1, B2, I mean, it just seems so, complicated. And then you're going to subtract A2 times B1. So you're going to multiply this way and that way on a diagonal and subtract those two answers. So it really actually is much easier than multiplying matrices. So let's look at this first one. So all you're going to do is you're going to do 5 times 3 is 15, subtract 7 times 6 is 42. So it really is just a really simple problem. So this determinant is negative 27, okay? So then this one, you're going to multiply 2 times negative 5 is negative 10, subtract a negative 3 times 4 is a negative 12. So just remember when you subtract a negative, and I'm sorry for my bad handwriting, it turns into a positive. So this one's answer is 2, okay? So then here we go. 5 times 10 is 50, subtract 6 times 9 is 54. So negative 4. Okay, so now the next thing, so that's how you do a determinant. The next thing can be a little complicated because it looks maybe harder than it is. So in order to solve a system of equations using Cramer's rule, you've got all this, the formulas, but the formulas kind of make it look worse than it actually is. So this, what I would consider where the constants are, gets like recycled 2 different times, okay? So the first thing that you want to do is you want to look at the coefficients of your equation. Okay, sorry, it's like, I wish that it would be all in one place so we could see it a little bit better. So this 5, this negative 4, this 6, negative 5 is very, very important. Okay, so we're going to end up using it. That is what is considered this A1, B1, A2, B2. Okay, super important. So to solve for the x, we're going to put, there's going to be 2 giant fractions. I'm sorry for the spacing on this. I was trying to get it all on the screen at once. So we're going to put 5, negative 4, 6, negative 5. And then this B1, B2, okay, is negative 5, negative 4. So you notice that those are perfect replicas of each other. Then for the y, I'm going to use 5, 6, negative 4, negative 5 all over again, okay? And then this time I'm going to use, if you notice, it has this A1, A2. Okay, so that's going to be this 5, 6. So now these two are replicas of each other. Okay, but then here's what goes in these 2 columns. It's this 2, 1, the constants that I was talking about. So this is going to have a 2, 1. This is going to have a 2, 1. And you'll notice, maybe, if you think about this, when I'm trying to solve the x, I'm using the constant column, in like the x position. When I'm trying to solve the y, I'm putting the constant column in the y position. Okay, so now all you have to do is find the determinants of all these little matrices. Okay, well, one nice thing is these 2 answers are going to be the same. Okay, so 5 times negative 5 is negative 25. minus 6 times it would be negative 24, but you're minusing a negative 24. So that's really going to be plus. So then this answer is actually negative 1. Oh, you cannot see what I'm doing. So sorry. Okay, so because these two things are the same, I know that a negative 1 is in the denominator of both of these. Now what's going to change are these top determinants. Sorry, I was about to say Cramer's. So 2 times negative 5 is negative 10. Okay, so negative 10 minus 1 times a negative 4 is a negative 4, but if I'm subtracting, it's going to be positive. So I've got a negative 10, positive 4. So what I have for this, so sorry, it's very crowded, is a negative 6 over negative 1. Okay, well then that makes the x actually a negative 5 by negative, makes that a positive 6. Okay, then this determinant, 5 minus 12 will be a negative 7. Okay, so the top of this is negative 7 over negative 1. So that makes the answer to this 6, 7.